This video is on the objective solve equations with a single trigonometric function. Now, you saw linear trigonometric functions in the previous assignment, where that single trigonometric function was to the first power, and that was the highest power. In this assignment, you're going to come across equations with a single trigonometric function, but you might see it to the second power, as high as as a quadratic. And hopefully you recall how to solve a quadratic equation from either pre-calc 1 or some previous algebra class you've taken. So let's take a look. So here, again, if you want to see more about this objective, click on More Instruction. Look at their videos, their notes, their examples. Hopefully those help you. Alright, so we're asked here to solve this equation. Negative 12 times, you see it's the cosine of theta, right? A single trig function showing up in this equation, but it's to the second power, right? So it's cosine theta and then, squared. So it's like a quadratic. And then plus 3 equals negative 3. And, this is, again, if any of these trig function equations have solutions, they're going to have infinitely many because the trig functions are periodic. But they're only asking for the values of theta that are solutions that are between 0 and 2 pi, not including 2 pi. Right. And they already have the theta equals, and they're asking us, enter the answers, and if there are multiple solutions, separate them by commas. Okay. So let me write this equation out. So we have negative 12 times the cosine of theta, squared. Remember that means cosine theta times cosine theta, plus 3 equals negative 3. Right. Now, if you want to do this, just to save a little writing, the unknown here, right, the thing that has no value, right? Negative 12 has a value, 3 has a value, negative 3. This cosine of theta, right? I don't know what that is because I don't know what theta is. So the unknown here is the trig function. What is the value of cosine of theta? And if you would like to, right, just to save a little writing, save a little time, you can substitute for this unknown, replace it with something, right, like a single letter. So say I substitute that with like x or something, right, some variable representing an unknown. So now this equation looks like this, negative 12 times, the cosine of theta squared. Right, so now it looks like this, negative 12 times x squared plus 3 equals negative 3. And then you solve for x, and then we're going to substitute back and solve for theta. Now you don't have to do this. Right? You don't have to do what I just did with the substitution. You can leave it as cosine theta squared, and hopefully you remember how to solve an equation like this. Right? When there's just a square term and no other terms with a variable, we can isolate that square. Right? Now if this was 3x here, if it was 3 cosine theta, then I'd have to solve it some other way, right? Hopefully you remember how to solve quadratic equations. But when there's only the square term, an easy way to solve it is to isolate the square, get the square alone. So that would involve subtracting 3 and dividing by negative 12. So we'd have x squared equals positive 1/2. Because if I subtract 3, that'll be negative 6 over here. Then divided by negative 12 would be positive 1/2. And then I take the square root of both sides. Now remember, there's two numbers that when you square it give me positive 1/2. One would be the positive square root of 1/2. Or, the other one would be the negative square root of 1/2. Both of those are equally valid. Those are both solutions to that equation. x squared equals a half. Now the square root of a half is 1 divided by the square root of 2, right? The square root of 1 is 1, square root of 2 is the square root of 2. And when you rationalize this, multiply the numerator and denominator by the square root of 2. That'd be the square root of 2 divided by 2. Right? Or, and over here, same thing, x could be negative square root of 2 divided by 2, right? Again, the square root of a half is equivalent to the square root of 2 divided by 2. Now, this isn't the end, right? Don't think this is over. I solved for x. I solved for my substitute variable. But the original equation had theta as the variable. I want to solve for theta. So once I've solved for my substitute variable, then we're going to substitute back, go back to the original variable. All right, and if I do this, we'll have these two equations to solve. X equals square root of 2 over 2, so that's cosine theta. Remember, x was representing cosine theta equals the square root of 2 divided by 2. Or cosine theta equals negative square root of 2 divided by 2. And I'll solve each one of these separately, and then we'll write down all the solutions that we're being asked to find. Right? So the first of these equations is, when is the cosine of theta equal to positive square root of 2 divided by 2? Alright, so this is now a linear equation in cosine, right? There's cosine to the first, and once it's alone, right? Once the trig function's alone in a linear equation, just think once around the unit circle, right? Just think about going around the unit circle one time, and what angles had a cosine of positive square root of 2 over 2? Well, one of those was pi over 4. Right, pi over 4 radians. So theta could be pi over 4, or, if I took pi over 4 here and just added 2 pi, subtracted 2 pi, you could add any multiple of 2 pi and you'd be back at the same spot. So you'd have another angle with a cosine of positive square root of 2 over 2. So I take pi over 4 and add, 2 pi times k, where k is some integer. But that's not all, right? Pi over 4 isn't the only angle with a cosine of positive square root of 2 over 2. So is this angle in quadrant 4 down here at 7 pi over 4. And not only at 7 pi over 4, but I could go 7 pi over 4 and then add 2 pi, subtract 2 pi, and keep doing that and end in the same place, get a coterminal angle with the same cosine. So another branch of solutions would be 7 pi over 4 plus any multiple of 2 pi. All right. So there's a description of all the solutions of this equation. But, we only want certain ones. Now I'm going to list some off. Right, here's a list of some solutions. Theta could be equal to. Now we got pi over 4, 7 pi over 4. Right, those are solutions when k equals 0. And then when I increase k by 1, it's just adding 2 pi. So going this way, I'm just going to be adding 2 pi, which is 8 pi over 4. Right, get a common denominator. And when I decrease k by 1, that'll just be subtracting 2 pi. So I'll go this way and say I'm subtracting 2 pi. All right, so on the top row, take pi over 4 as a solution. If I keep adding 2 pi, I'd get 9 pi over 4 is another solution, and 17 pi over 4 is another solution, and so on. Subtract 2 pi, you get negative 7 pi over 4 is a solution. Negative 15 pi over 4 is a solution, and so on. Again, I could do that all day long. Then the second row, 7 pi over 4 is a solution. And then keep adding 2 pi, you get 15 pi over 4. Then 23 pi over 4, and so on. Right? Or subtracting 2 pi, you get negative pi over 4. Negative 9 pi over 4, right, and so on. Right. So there I've just shown you 10 solutions to this equation. And if you're a solution to this equation, you're a solution to the original one that we had with. But remember, they want not all these solutions. Right? We want solutions that are from 0 to 2 pi. Right? They only want solutions from 0 to... Now 2 pi again is 8 pi over 4. So looking through this list, pi over 4 is in there. Then these are too big. These are too small. And then 7 pi over 4 is in there. And these are too big. These are too small. So the only solutions I'm getting out of this first equation that are in the range that I want are between pi over 4 and 7 pi over 4. Okay. All right. Then the second equation, is where is the cosine of theta? All right, where is the cosine of theta equal to negative square root of 2 over 2? All right. So again, I get the trig function alone when it's linear like this, and it's already done for me. And I just think, once around the unit circle, what angles have a cosine of negative square root of 2 over 2? Well, that would be 3 pi over 4 and 5 pi over 4. All right. Those would have a cosine of negative square root of 2 over 2. So when I'm writing the general solution, theta could be replaced by 3 pi over 4, but then plus any multiple of 2 pi, right? So plus 2 pi k, where again k is an integer. Or theta could be replaced by 5 pi over 4, and then plus any multiple of 2 pi. Now, I'm not going to do the listing solutions this time, because hopefully you see that if I take 3 pi over 4 and add 2 pi or subtract 2 pi, the solution will be too big or too small to be in that range, from 0 to 2 pi that they want. Right? So theta equals 3 pi over 4 and 5 pi over 4, same thing. 5 pi over 4 is a solution to this, and when I add 2 pi or subtract 2 pi, I'll be too big or too small. So these solutions are coming from this equation, and these solutions are coming from the first equation. So all together I'm going to enter these 4 answers: pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. All right, when I go and enter the solutions they want in the exercise. So here we go. Pi over 4, comma, 3 pi over 4, comma, 5 pi over 4, comma, and finally 7 pi over 4. All of those are in that range from 0 to 2 pi, and they all satisfy this equation. And you can check them by plugging them in to see if they work in this quadratic equation here, but they should. Okay, and again, hopefully watching me do this, looking at the more instruction, reading the answer explanations when they come up, hopefully all this stuff helps you when you're looking at, when doing this stuff on your own. And thanks for watching.